Hello everyone, my name is Nidhi Chauhan. I'm assistant professor in the School of Pharmacy that is a part of the University Jaipur. Today we are going to discuss the topic that is the carbonyl compound, aldehyde and ketone. So this comes in a pharmaceutical organic chemistry first, that is in your second semester from first year. So the learning objective of this topic is this, that here we are going to study about the ketones, that what are the ketones, and also we are going to study about the physical properties of ketones, that what are the physical properties of its ketone, what is its boiling point, what is its melting point, and also we are going to study about the chemical reactions of ketones, that how can the ketone is reacting with other reagents and it is forming the product. And also we are going to study about the reactivity of the ketones of different molecules. So here the physical properties of ketone involves its boiling, melting, as well as its color, order, and its solubility in water as well as in other solvents. So here these are the learning objective, and the student outcome is that they will going to know about what are ketones, and they will also learn about the properties of ketone, that in physical and chemical properties of ketone, and also the relative reactivity of ketone. And they will also be going to know about the chemical reactions of ketone, means how ketones are chemically reacting on the industrial scale and the industrial scale or the lab scale. So how these are giving reactions to form another 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 product, and the with the help of the catalyst or without catalyst. We are also going to study about the aromatic ketones as well as. So here are the physical properties of this ketone. The physical properties of ketone is that lower ketones are colorless liquid, means the ketones which are lower, they are colorless liquid, and they also possess a pleasing and sweet odor. Means here they are colorless liquid, means they have no color and they are present in the form of liquid. And these lower ketones, they are possessing pleasant sweet odor, means here sweet and pleasant odor they are having. So the density of ketone is less than water. So here the density of ketone is your less than water, and the density of ketone, as discussed in aldehyde unit, ketones have higher boiling point than corresponding alkane, but lower boiling point compared with those of alcohol of comparable molecular weight. So here these as we have discussed in the aldehyde unit, in our last unit also you can see that videos where we have discussed aldehyde unit. So the ketones have higher boiling point. Ketones are having the higher boiling point as compared to the alkane. So in comparison to the alkane, they have the higher boiling point, but lower boiling point compared with those of alcohol of comparable weight, molecular weight. Means here the ketones which have the similar weight with the alcohol, uh, ketones which are having the same and same molecular weight of alcohol and the ketone, but the ketones are having the lower boiling point as compared to this alcohol. So here the boiling point and the boiling point and melting point molecular weight is given here. So here you can see this is your alkane. So its molecular weight is 58, and the second structure is your acetone, that is your ketone, and it is also having a molecular weight 58. And third is your alcohol. Alcohol is also having the molecular weight 16. So here you can see that the boiling point of this isobutane is 12 degrees centigrade, acetone is your 56 degrees centigrade, and isopropyl alcohol is your 82.5 degrees centigrade. So in this case, you can see the molecular weight of this alkane and this ketone is almost similar, but their boiling point is different as compared to this. Alkane, the ketone have the higher boiling point compared to this ketone. And as compared to this alcohol, ketone has the lower boiling point uh, compared to this alcohol, which have the same comparable molecular weight. Ketone is having 58 and the alcohol is having 16. So the lower ketones are soluble in water as they form hydrogen bonding with water. As alkyl chain of molecule increases, solubility in water decreases. As we know that the alkyl portion which is attached to the ketone in the lower, their small alkyl groups are attached to this ketone molecule. So in this case, the ketone forms hydrogen bonding with the water molecule. So they are soluble in the water. But in case of as the alkyl chain increases, the hydrophobicity increases, and that is why the solubility in water also decreases due to this alkyl chain of molecule increases. So in infrared spectrum, strong P11O stretching band is observed in 1740 centimeter inverse region. So the in infrared spectrum, you can see this carbonyl group C11O. Its band is showed at 1700 to 1740 centimeter inverse region. Next is the relative reactivity. So as discussed in detail in the aldehyde unit, it is noted that relative reactivity of ketone is less than aldehydes towards nucleophilic addition reaction. So here you can see, so here we have discussed already in aldehydes the relative reactivity of that aldehyde, but here we are discussing this relative reactivity of ketone, which is less than aldehydes towards a nucleophilic addition reaction. So here the relative reactivity of ketone is less than aldehydes towards nucleophilic addition reaction. So they are less reactive towards the nucleophilic addition reaction. And here, electron releasing alkyl group, the electron releasing alkyl group that is present on the ketone that reduces positive charge of carbonyl carbon and thereby decrease reactivity of carbonyl group. So the alkyl group that is present, because the alkyl groups are electron releasing groups, because they have the capacity to donate electron. That is why they are reducing the charge that is present on the carbonyl carbon, and therefore they are decreasing the activity of this carbonyl group. So here, moreover, as compared to hydrogen atom, alkyl group increases. Moreover, as compared to hydrogen atom, alkyl group increases steric hindrance for attacking reagent to reach its carbonyl group. As you know that in case of alkene also we have studied that the sorry, not in alkene, we have studied in the SN and SN2 that the alkyl groups are bulky groups, and when more than one alkyl groups are attached to the carbon atom, then they also increase the steric hindrance. And the attacking reagent, that is a nucleophile, is nucleophile become less reactive, or if they cannot attack the carbonyl carbon, and they have difficulty in attacking the carbonyl carbon. So as compared to H atoms are attached to the carbonyl carbon, then the attacking reagent can be fast. Attack can be fast of this nucleophile. But if the alkyl groups are attached to the carbonyl carbon, then the steric hindrance increases for the attacking reagent. Secondly, after attack, sp2 hybridized carbonyl carbon become sp3 hybridized in resultant adduct. Means here, if after the attack, sp2 hybridized carbonyl carbon become sp3 hybridized in resultant adduct. So here, sp2 hybridized carbonyl carbon, after the attack of the nucleophile on the carbonyl carbon which was sp2 hybridized first, that become sp3 hybridized, and there is a resultant of the adduct which is due to the addition of the nucleophile. So here bond angle are reduced from approx 120 degree to around 109 degree. If the carbonyl carbon that was sp2 hybridized, in that case the angle bond angle is your 120 degree, and if the fourth nucleophile attached to this carbonyl carbon, then it's the bond angle become 109 degrees centigrade due to the carbonyl carbon, as the carbonyl carbon become your sp3 hybridized. So this adduct also gets steric strain due to increase of bulky group. So here the adduct that is formed, they also get steric strain due to increase of your bulky group. So this strain is higher in ketone as compared to aldehyde. So the strain um, that is formed by the addition of these two adduct, which is due to the increase of bulky group. This is much higher in ketone as compared to your aldehyde. So this is the structure of your aldehyde. Secondly, it is the structure of your first it is the structure of your this ketone, and then this is the structure of your aldehyde. This is your paramethyl aldehyde and benzaldehyde, and this is also your benzaldehyde, and this is your nitro benzaldehyde. So in this case, you will see this nitro is an electron withdrawing group. So this will withdraw electron, and the reactivity of this carbonyl carbon increases. So that is why in this case there is a reactivity is more, and in this case there is no attachment of any electron donating or electron releasing species. That is why it is much lesser than the reactivity of this aldehyde is much lesser than the and then the electron releasing group that is attached to the this aldehyde. Next, the relative reactivity of this para methyl aldehyde is much lesser than ethyl, because here methyl group is attached to this benzene ring. Methyl group is attached to this benzene ring. So that is why it is having the capability to donate or release electron. So this will release electron, and there is a formation of this aldehyde. Next is your this ketone. So the ketone is having much lesser relative reactivity as compared to these compound, because this CH3 group is present just nearer to this carbonyl compound. So here the relative reactivity of ketone is less than aldehyde towards nucleophilic addition reaction. So here electron releasing alkyl group, they reduce positive charge of carbonyl carbon, and thereby decreases reactivity of carbonyl group. And moreover, as compared to hydrogen atom, these alkyl group increases the steric hindrance of for attacking region, that is a nucleophile. So these alkyl group which are attached to the ketone molecule, carbonyl carbon of the ketone molecule, they are increasing the steric hindrance, and it caused difficulty to this nucleophile to attack on this carbonyl carbon. So alkyl group increases steric hindrance for attacking reagent, that is a nucleophile, and to reach at carbonyl carbon. Secondly, after attack, sp2 hybridized carbonyl carbon become sp3 hybridized. So this sp2 hybridized carbonyl carbon is your firstly it was sp2 hybridized, and after the addition of the nucleophile on the carbonyl carbon, it becomes sp3 hybridized, and there is a formation of the tetrahedral structure. That is why the bond angle which was approx 120 degree in case of sp2 hybridized carbonyl carbon, that is reduced to 109 degree. So here, because in case of tetrahedral, the bond angle is your 109 degree. So this adduct also gets steric strain due to increase of bulky group. So here, as there is an increase in the alkyl bulky group, means here alkyl group. So these abduct that is formed also get the steric strain. So this strain is higher in ketone as compared to aldehyde. So this strain is higher in case of ketone as compared to aldehyde, because aldehyde is attached in aldehyde, the carbonyl compound is attached to the hydrogen atom, and in case of um, this ketone, both side the carbonyl compound, carbon that is present, the carbonyl carbon that is bonded to the two alkyl group. That is why the steric strain in this ketone increases, is higher as compared to aldehyde. Next, you can see this is the steric strain. So acetophenone is ketone. This is your acetophenone. This is the acetophenone is ketone, while other three are aldehyde. So these all are aldehyde, as I told you earlier. So these all are aldehyde. Then this is a ketone, and the relative reactivity of ketone is much lesser than this aldehyde. So acetophenone is ketone, while other three are aldehyde. So acetophenone is least reactive. So acetophenone is least reactive. P-tol aldehyde. This is your para methyl aldehyde. Um, then this is also the same. P-tol aldehyde has electron donating methyl group at the para position of benzene. So here you can see this methyl group is present on the para position of this aldehyde ring, whereas P nitrobenzaldehyde. So here P nitrobenzaldehyde has an electron withdrawing nitro group. So this is having the electron withdrawing property, the nitro group. So here we know that the reactivity of carbonyl group is inversely proportional to electron density at carbonyl carbon. So p-tol aldehyde is less reactive as compared to benzaldehyde, or you can say less reactive than benzaldehyde, while p-nitrobenzaldehyde is more reactive than benzaldehyde. Alpha hydrogen of ketone are acidic and removable by soft strong base. So here you can see that acetophenone, which is a ketone, is having the lesser relative reactivity as compared to the three aldehydes which are shown here, and the acetone is having least reactive, and the p-tol aldehyde which is having the CH3, that is your methyl group present on the para position, and it is the capability to donate electrons, releasing, or you can say release electrons. So these are, whereas this nitro that is attached to the para position, it has a property to withdraw electron. This property at the para position, that the this reactivity of carbonyl group is inversely proportional to the electron density at carbonyl carbon. So p-tol aldehyde is less reactive. So p-tol aldehyde is less reactive than the nitro p-nitrobenzaldehyde, or you can say your benzaldehyde, because the electron density is carbonyl carbon, so P is reactive than the benzaldehyde, while P nitrobenzaldehyde is more reactive than your benzaldehyde. Alpha hydrogen of ketone are acidic and removable by a strong base. The alpha hydrogen that is present on this CH3 are more reactive, are acidic in nature. That is why they are removed from here and form a bond with the strong base. Now the chemical properties. So the ketones are reactive organic compound and undergo many reactions like aldehyde. Like aldehyde, ketones are also reactive organic compounds, and they show many reactions like your aldehyde. First is your addition reaction. So in your addition reaction, like aldehyde, the reactive carbonyl group of ketone give addition reaction. So these ketones also give addition reaction like your aldehyde. So in case of aldehyde also, they give this addition reaction. So like aldehyde, these ketones are also reactive in giving the addition reaction. So first is the addition of sodium bisulfite. So sodium bisulfite formula is NaHSO3. So this is sodium bisulfite. So ketone add on sodium hydrogen sulfide and form adduct called bisulfite addition compound, which are water soluble salts. So here ketones are forming a sodium hydrogen sulfide, and they are also forming an adduct, that is your bisulfite addition compounds, and these are water soluble salts. So these are also water soluble salts. So addition of sodium bisulfite, the ketone add on sodium hydrogen sulfide, and these are forming adduct called bisulfite addition compounds, which are water soluble salts. So this addition of sodium bisulfite and this ketone, and they are forming a salt, that are your that salt are your water soluble. They have the ability to dissolve in water. So now here you will see this ketone is reacting with this sodium hydrogen bisulfite, sodium bisulfite or sodium hydrogen bisulfite. So you can see here, if this is sodium bisulfite is reacting with this ketone, there is the addition of this SO3 sodium sulfate add to this sulfide added to this carbon, and this hydrogen is removed from here. It means here is a dissociation between this H and this NaSO3, and H will get the positive charge, and this NaSO3 will get the negative charge. So here you will see that NaSO3 negative will react to the partially positive carbon atom, and this H will react with the partially negative O oxygen atom. There is a formation of this bisulfite compound, and or you can say the bisulfite salt. So the formed adduct, when treated with acid or base, it gives corresponding carbonyl compound. So here this adduct, that is your this adduct, when it is reacting with any acid or any base, then it is giving the carbonyl compound. So here this is your bisulfite and this is your adduct, and when we are reacting in the presence of this acid, that is your HCl, and or you can mineral acid, or this is your H2O. Hydrogen water, in the presence of water also there is the formation of this ketone and NaCl, H2O and SO2. And when we are reacting this bisulfite salt in the presence of this base and H2O, that is the water, then there is a formation of this ketone, sodium sulfide, and sodium bicarbonate. So here, from this first reaction is the addition of with sodium bisulfide, sodium hydrogen bisulfide. So here you will see that there is a formation of a bisulfite salt, and when this bisulfite salt is reacting with this, or you will say this adduct is reacting with this, treating with this acid or base, then we are getting a corresponding carbonyl compound. So this salt is reacting in the presence of your acid, and there is a formation of this ketone plus NaCl plus H2O, SO2. And next, when this salt is reacted in the presence of this base, that is your Na2CO3 and H2O, then there is a presence of this, there is a formation of this ketone and sodium sulfate, and the sodium bicarbonate is formed. Yeah, NaHCO3, Na2SO3, and RCOR is formed. This is your ketone. The mechanism of this reaction with sodium hydrogen bisulfite, and here you will see that in this reaction Na2SO3 act as a nucleophile through sulfur and attack at carbonyl carbon, which is followed by protonation of carbonyl anionic oxygen by bisulfite ion. So here this NaSO3 is dissociated, and there is a formation of this Na plus HOS double bond O minus, and here when this is reacting with the water molecule, there is a formation of this hydrogen ion, as well as this sulfur oxide product is formed here. So here you will see after that this will react to the carbonyl carbon, which is having a positive charge on it, and this oxygen will withdraw electron from this carbon atom, and there is a formation of this sulfide compound. So here in this reaction, the sodium sulfate It acts as a nucleophile to sulfur and attack at carbonyl carbon, which is followed by protonation of carbonyl anionic oxygen by bisulfide anion. And here you will see NaHSO3. This is dissociated in Na plus HOS double bond O negative anion, and this anion then is reacting with this HOH, that is your hydro water molecule, and there is a formation of this hydronium ion, and this SO3 is formed here, and this SO3 is reacted to the carbonyl carbon, and there is a formation of this compound, that is your anionic. Next is your, so this anionic product that is formed, that is reacted with this HSO3, and there is a formation of this product. This is a reversible product. Second is your addition of hydrogen cyanide. If hydrogen cyanide is attached to your ketone, then what will be formed? Then ketone at HCN, that is your hydrogen cyanide, in the presence of base catalyst to form cyanohydride, which can further be hydrolyzed to COOH group. So here, ketone is reacting with this HCN in the presence of base catalyst. So here we need a catalyst, and there is a formation of cyanohydrine, and after that the cyanohydrine is formed. The cyanohydrine can be hydrolyzed to your COOH group. So here you will see this is your ketone, and ketone is reacting with this HCN, that is your cyanohydrine hydrogen cyanide. And this hydrogen cyanide, when is reacting with this ketone, there is a formation of this cyanohydrine product. This is a ketone, HCN is reacting, and the cyanohydrine product is formed. This is a benzophenol, and this is reacting with this HCN. There is a formation of a cyanohydrine product. So here you can see the CN is reacting with the carbon atom and the H. So here is a dissociation between this HCN and HCN dissociation. That H is positive and CN is negative. So here HCN is your nucleophile. This nucleophile will attack the carbonyl carbon, which is having the partial positive charge, and the oxygen is having the partial negative charge. So this partial negative charge will react to this carbonyl carbon, and there is a formation of this and after that the addition of this CN to the carbonyl carbon, the H, which is having the positive charge, will react to the oxygen, which is having the partial negative charge. So there is a formation of this cyanohydrine. So here there is a formation of this cyanohydrine product. The next is the benzophenol, and it is reacting with this. This is the aromatic product, and which is reacting with this HCN, and there is a formation of this cyanohydrine product is formed here. Next, addition of Grignard reagent, that is your RMGX. So ketones react with Grignard reagent to form complex which on hydrolysis give which on hydrolysis with dilute acid give tertiary alcohol. So here you will see this is a ketone, and on this ketone is reacting with this RMGX, and this oxygen is withdrawing electron from this bond, and this is your O that is having the partial negative charge, and this carbon that is having the partial positive charge. So this R is also this RMGX, which is a Grignard reagent, also dissociating, and this dissociation is dissociation, this R negative will react with this C positive that is having the partial positive charge, and there is a formation of this, and MgX will react, which is a nucleophile and its electron, that is why it is reacting with this oxygen atom. So this MgX is reacting with this X is reacting with this O, and there is a formation of this intermediate. After that, it is hydrolyzed in the presence of the dilute acid, that is your dilute HCl we have taken here, and there is a formation of this alcohol, that is your tertiary alcohol is formed. and MgXOH is formed here after that. So here you will see when the ketones are reacting with this RMGX, which is your Grignard reagent, then there is a formation of this intermediate is formed here, and after that this intermediate is hydrolyzed with your dilute acid. There is a formation of this tertiary alcohol is formed here. So here this ketone is reacting with this Grignard reagent, and there is a formation of the Grignard intermediate, and this intermediate is then hydrolyzed in the presence of your HCl. There is a formation of this alcohol is formed here, and water molecule is formed here. So this is your aromatic compound, that is your this product, and this is your acetophenone. When this acetophenone is reacting with the Grignard reagent, there is a formation of this intermediate, and after that this is hydrolyzed in the presence of dilute acid, and it gives you this alcohol. This is your tertiary alcohol. So the tertiary is having all the three alkyl group that is attached to the carbon atom, and one is bonded to the OH group. So addition of ammonia. So in case of addition of ammonia, the ketone is reacting with this NH3, that is your ammonia, and it is forming a complex condensation product. So here you will see that this is your ketone, and it is reacting with this ammonia. Then there is a formation of this diacetone amine is formed here. So this ketone is reacting with this ammonia, and there is a formation of this diacetone amine. Means diacetone amine is formed because on this carbon atom, the amine part, that is your NH2, is attached to the carbon atom, which is already attached to the two alkyl groups. This is your diacetone amine that is formed by the reaction between the ammonia as well as this ketone. So this is your acetophenone, and when it is reacting with this ammonia, then there is this product is formed here. This ketone product is formed here. This ketone product is formed here. Next is your addition of terminal alkynes. So here, when these alkynes are attached to this ketone, then what will be formed? So here, the ketones react with sodium salt of terminal alkynes, and it gives alkynyl bond. So here you will see this oxygen is withdrawing electron, and this is your alkaline, that is a sodium salt of alkaline. So in one side you will see there is the Na positive is attached, that forming its sodium salt, and this sodium salt is reacting with this ketone, and there is a formation of this anion, and after that this anion is hydrolyzed in the presence of this water molecule plus H positive and acidified also, and there is a formation of this this alcohol, or you can say alkynyl form is there. Nol is for your alcohol which is attached to this molecule, and alkyl is for your alkyne part that is attached to this molecule. This is your alkynyl is formed. Alkynyl. So in the second, this is the mechanism that is given here. So in this, you will see that oxygen is withdrawing electron, and the Na part will attach to this portion. So here you will see after that it is hydrolyzed, and there is a formation of this alkynyl. Alkynyl is formed. Alkynyl is formed here. Here you will see that this alkynyl is formed from this ketone molecule, which is reacting with the sodium salt of your terminal alkyne. Next is your addition of alcohol. So this alcohol, this ketone, is reacted with the alcohol in the presence of acid or base catalyst and form a hemicatal. So here hemicatals are less stable than hemiacetal. So here this ketone is reacting with the alcohol and in the presence of acid or base catalyst, and they are forming a hemiketal is formed here. So here you will this hemiketal which are formed here from this ketone by reacting with this alcohol. They they are less stable than the hemiacetal. Next here you will see that there is a reaction. You can see here the water molecule is added to the carbon, and from here this oxygen will withdraw electron and this water molecule is removed out from here. So there is a removal of water molecule also. And after that, this R3OH, that is your alcohol, is attaching or attacking to the carbonyl carbon, and this oxygen, you can see here this oxygen is withdrawing electron from here, and this oxygen which is having the lone pair, that is donating this lone pair and forming a bond between this carbon and oxygen. So this structure is formed here. So this structure, after the alcohol is attaching to this carbon, and you will see there is a formation of this bond. Here the bond is formed here, and after that this OR from here, you will see this hydrogen. This hydrogen is removed from here. There is a removal of this hydrogen atom from here, and there is a formation of this acetal or this ketone. So here you will see this ketone is reacting with this ethyl alcohol, which in the presence of the catalyst, that is your acidic catalyst, and there is a formation of intermediate is formed here. This O will attach to this carbon portion, and this C2H5 will react to this this carbon portion, and there is a formation of this hemiacetal is formed here, which is again converted into your acetal or your ketone, and this C2H5O is removed from that side, and this acetal or your ketone is formed from this. So hemiacetal of ketones are sometimes called hemiketals. Also, in the above reaction, excess of alcohol and removal of water leads reaction forward, and excess of water favors backward reaction. Ketone don't form ketals readily as formed by aqueous dioxin, and the solution of dioxylane on treatment with periodic acid regenerates ketone, and aldehydes ketones may, however, be prepared by treating the ketone with ethyl orthoformate. And here you will see this ketone is reacted with this alcohol, and there is a formation of this acetal is formed here. So here C2H5, COOH, and your this ethyl carboxylic acid is also formed here. So here aldehyde and ketones may, however, be prepared by treating ketone with ethyl orthoformate, and this is your ethyl orthoformate. This is your ethyl orthoformate, and it is reacting with your ketone, and there is a formation of this product is formed. So ketones readily react with 1,2-glycol to form dioxylane or cyclic ketone. So this this ketone is reacting with this 1,2-glycol, and here there is a formation of this cyclic ketone is formed here. After that, there is a formation when this is reacting with this HiO4. There is a formation of this formaldehyde as well as this ketone is formed here. Next, addition of mercaptan. So in this, the thiol reacts more rapidly than alcohol to more rapidly to give thioketone. So this ketone is reacting with this thiol ketone, and there is a is reacting with this ketone is reacting with this mercaptan, and there is a formation of the thioketone. So here you can see this ketone is reacting with C2H5SH. This is a mercaptan, and there is a formation of this thioketone. And this is the aromatic portion which is reacting with the mercaptan, and there is a formation of this product. Then addition reaction followed by elimination. So ketones like aldehyde combined with nucleophilic and eliminate neutral molecules like H2O. The addition reaction of ketones followed by elimination are being described as follows. So eighth reaction is the addition of ammonia derivative. So here nucleophile of type Y, NH2 or OH, they combine with ketone and there is a formation of carbon nitrogen double bond and followed by the elimination of water molecule. So here there is a formation of this carbon nitrogen double bond is formed and the water molecule is also removed from here or eliminated from here. So here you will see the mechanism, this NH2 which is having a lone pair, they will attach to the carbonyl carbon and here the nitrogen is having a positive charge and from here this H is removed from here and it will removed as a proton and it will attack the oxygen portion which is having a negative charge. So here there is a formation of this alcohol because of the transfer of H positive and after that there is a formation of this product is formed between carbon and nitrogen and double bond is formed. Next, this is the above reaction which is catalyzed. So here ketone, as you can see the ketone is reacting in the presence of your hydroxylamine and there's a formation of this endoxium and when this ketone is reacted with this N substituted hydroxylamine there is a formation of this nitro and when this ketone is reacted with this hydrogen there is a formation of this hydrogen and ketone is reacted with phenyl hydrogen there is a formation of phenyl hydrogen and when ketone is reacted with 2,4-dinitro phenyl hydrogen there is a formation of 2,4-dinitro phenyl hydrogen. And when this ketone is reacted with semi-carbazide, there is a formation of semi-carbazole. So phosphorus pentachloride reacts with carbonyl compound. When this ketone is reacted with phosphorus pentachloride, there is a formation of this product is formed. This POCl3 is formed. Ketone react with aldehyde. Your aliphatic primary amine, there is a formation of PTamine. So here you will see this ketone is reacted with your primary amine and there is a formation of this PTamine. Next is the mechanism of this. Here you will see that this ketone is reacting with this acid halide and there is a formation of this anion. Cation is formed here and after that this cation, this positive portion is reacted by this primary amine. There is a formation of this ketamine. Next is your at pH 7 formation of I is fast and as acidity increases dehydration also increases. However, if acidity increases further then first step addition of nucleophilic nitrogen of NH2 group decreases as acidity form non-nucleophilic nitrogen conjugate acid. So here you will see this primary amine is reacted with this H3O4. Well, that is your hydronium ion that there is a formation of non-nucleophilic SH2. So reduction reaction. So the carbonyl group of ketone can be reduced to CH2 or CH by using reducing reagent. In continuation to other reactions, the reduction are as follow. The ketones are reduced to a secondary alcohol when treated with hydrogen and nickel and hydrogen and PP, that is platinum, and your lithium aluminum hydride in tetrahydrofolate, a sodium borohydride, and water or alcohol. So here you will see that there is a reduction of unsaturated ketone with this sodium, with hydrogen and nickel, and heat pressure is applied. And there is the double bond is hydrogenated, or the both double bonds are carbonyl groups are hydrogenated. But here only carbonyl group cannot be hydrogenated. This is lithium aluminum hydride and sodium borohydride type metal hydride reduces carbonyl group, but not isolated carbon-carbon double bond. So this C double bond C in conjugation this carbonyl group is sometimes reduced and this sodium borohydride is milder reducing agent than your lithium aluminum hydride. So sodium borohydride is used in a selective carbonyl group if carbonyl and ester groups are present in the same molecule. Next is your Melvin-Pondorf Verily reduction. In this we have also discussed in the aldehyde also. So ketone are also reduced to a corresponding alcohol when dissolved in solution of isopropyl alcohol containing aluminum isopropoxide. So here you will see that ketone will here forming a complex and there is a formation of this alcohol plus ketone. Next is your reduction to hydrocarbon. The first is the chemical reduction. So in this, the carbonyl group of ketone is reduced to methylene group by using zinc amalgam and hydrochloric acid. So this ketone in the presence of zinc, hydrogen, mercury, that is a zinc amalgam, is the formation of this alkene. So this ketone is reacted and there is a formation of this ketone alkane. So this is your Wolff-Kushner reaction. In this, you will react with this hydrogen. This ketone is reacted with hydrogen, and there is a formation of this hydrogen at 180 degrees centigrade, and there is a formation of this alkane is formed here, and nitrogen is evolved out from here. So in the reaction that is carried out at room temperature in the presence of polar solvent like your DMSO. So in this, the alpha beta unsaturated carbonyl compound, the Wolff-Kushner reduction leads to double bond migration. So here there is a migration of this double bond, and this when it is reduced by the metal, that is the manganese, and in neutral or the acidic medium forms phenols. So this is your phenols under acidic condition which undergoes rearrangement to form phenolphthalein. This rearrangement is known as phenol on a rearrangement, and this reaction is given by only ketone, not aldehyde. So this phenol in this acid hydrolysis is happening. After that, there is a formation of this phenolphthalein. You can see here this OH H is attached to this OH, and there is a removal of this water molecule, and this HC is having a positive charge, so this is also removed from here, and this bond will shift to this. This will transfer. Alkyl shift will occur here, so this alkyl will shift to this position. So and there is a formation of this carbocation is formed here. After that, this carbocation H will also withdraw from here, and there is a formation of the double bond. So this phenolphthalein is formed here. Next is your questions. So the IUPAC name of ethyl isopropyl ketone is 2-methylpanthenone. Acetophenone is prepared by which reaction? The Friedel-Crafts reaction. In C, double bond O group sigma bond is formed by sp2p overlapping. Which one of the following compound is prepared in the laboratory from benzene by a substitution reaction? That is acetophenone. The pi bonding carbonyl group is formed by pp overlapping. Ketones are prepared by which of the following reaction? That is open oxidation. Isopropyl alcohol on oxidation give which of the following? That is acetone. One of the following can be oxidized to the corresponding carbonyl compound, that is your 2-or-hydroxypropane. Which of the following compounds give a ketone with Grignard reagent? Methyl cyanide. Propional hydrolysis in presence of HCl and hygroscopic, this HgSO for mercury sulfate gives which of the following? That is your acetone. So these are some of the references from where you can study this topic. Thank you so much for today's lecture.